afternoon, everybody. Welcome to Occ-COVID Conversations, Health Impact Lessons and 2024 Workplace Choices. This webinar is called Managing Mask Madness, Benefits, Challenges and Solutions. So really we want to talk about the key tool in the fight against aerosol hazards, but much maligned and misunderstood. And we want to review the latest research controversy and the new CSA standards. So we wanted to run this webinar because there's a revision to CSA Z 94.4 selection, use and care of respirators. So I've just provided in the title slide up the top corner there. But you know, respiratory protection is only one piece of protection in a layered approach, and so I've just put the infographic in there, close the gaps. We all know that respirators are much more superior than surgical masks, and this is an infographic just to show that that have much better protection. N95 fit tested respirators provide, and even elastomerics provide even better protection as well. So it only works right if the fit is tight. We've had a number of surges of COVID, and the next pandemic could be around the corner, but this pandemic certainly isn't over. The most important thing is respirators provide both personal protection and source control. So that's an important piece of our toolkit. I just provided some hyperlinks to where you can go back to past webinars. We've run lots and lots of webinars, and if you think about the 11th being the 4th anniversary of the pandemic, being announced as a pandemic, and here we are 4 years later. We've provided lots of sessions through OCAO, and I just want to introduce our speakers. The first speaker is Dr. Mark Ungren, who's into interdisciplinary biomedical research. He's a researcher and associate professor at the University of Calgary. And it's really wonderful to have Dr. Simon Smith back again. He's a respirator science. And just if you look at the slides, I'll talk about the publication that Mark was part of in a minute. But also I want to add that it's so important that with this new standard out for public comment, for people on the call to actually have a look at the draft standard and provide public comment back. And that's just where you go to get the draft standard. So just to start off with Simon Smith, you look at how many different committees that Simon's in. And, he's the chair of the Canadian Standards Biological Aerosols Working Group. That's been very active, that's fed into the standard. And I just want to make mention that he's also a recipient of the Canadian Standards Association Award of Merit. And this is kind of some of the background behind that outstanding award. And, Dr. Simon Smith is retired, and he puts a huge amount of time into his volunteer work. So we're all very grateful for that. And we've also been very active, many of us, Simon, Mark and I, critiquing a study by Loeb et al. And you can actually look at all of the comments. There's 25 comments against this paper. And I've just put a comment here from Dr. Lisa Brosseau talking about the study being an ethical study without a control. We did provide a letter to the editor-in-chief of Annals of Internal Medicine, and our concerns were ethical issues, lack of interdisciplinary involvement, study design results, and the dangers of misinterpreting the results of the study. And they're all the names of the people that signed up against this letter that went to the chief editor. Now, just want to go to this article. Masks work, distorting science to dispute the evidence doesn't. And it's just really important that you can have a look at this and just talk about the forces behind, you know, saying that surgical masks are equivalent to N95 respirators, which they aren't. So if you look at the authors in this article, we've had Matthew Oliver before, we've had Joe Vipon before, and now we've got Mark Ungren, who's one of the co-authors to this article. So what I might do now is stop sharing, and if I can, stop sharing. Can you still hear me?
Yes.
I'm just trying to stop sharing. Okay, there we go. Stop sharing. All right. So what I might now do is hand you all over to Dr. Mark Ungren, and we're all very grateful for you to spend time with us, Mark, and I'll hand it over to you. Thanks very much.
Thank you very much for that intro, and that was a perfect lead-in. I will just now figure out if I can share my screen. There we go. Okay, so hopefully you can see my title slide there. And yeah, that was a really kind of perfect lead-in because you know, when I was asked to come on, one of the things I didn't want to do is kind of step into this space where there's so much expertise on you know, the technical and functional aspects of the masks and N95s and all kinds of PPE, and you know, it's a little intimidating. But what I thought I would do is look at the science, because that is my specialty, around, you know, how exactly did we get here, right? How is it that we're in this situation where, you know, we just saw all those different awards and qualifications and expertise and everything that Simon's involved in, and I saw, I think it said vast amount of expertise on that award page. So how is it that we have all these people with this vast amount of expertise and information and understanding of PPE and how it works, and there's any sort of debate? Because there doesn't seem to be any dispute among the people who actually know what they're talking about. And this is an area that I've been, I mean, I guess, you know, specifically this part interested in through the pandemic, but I have a long-standing interest in rigor, reproducibility, and efficiency in science, right? I kind of think of a science lab as a machine for turning resources and funding into new knowledge. And it's always been of interest to me to understand how we can do that efficiently. And so, of course, you know, rigor of science, if you waste money on bad science, or even, you know, you can even go in a negative direction by misinforming people. So yeah, I'm going to focus particularly on that part. So, you know, why is there so much misinformation around about PPE and protection, respiratory protection, and how do we fix the situation? So, yeah, where's it come from? So often we associate the problem with this sort of anti-vax position, right? Anti-vax, anti-mask, and you know, there's definitely a lot of that out there, but that part's actually easier to deal with as it's fairly widely recognized. But the more dangerous kind of misinformation and disinformation is what appears to come from the public's perspective, from sort of inside the house, where it's disguised as if it were science, right? And so that's both directly bad, because obviously it's wrong information, but also it erodes trust in scientific approaches overall, because ultimately people discover that, well, actually, you know, what we were told was quote unquote the science yesterday turns out to be wrong. And so I think, to my mind, it's really important to try and put some daylight between some of the things that are pushed as scientific but actually aren't, and then, you know, really rigorous scientific efforts. So a critical distinction that I'd really like to see everyone make is between the medical literature and the scientific literature. So this is a quote from Dr. Marcia Angel, who was, I believe, the first female editor-in-chief of the New England Journal of Medicine. And that is really, it's the oldest and one of the most prestigious medical journals out there. So this is, you know, not just some random quote I've picked off of Twitter, right? This is pretty authoritative. And I always tell my students not to read things off slides, but I feel like I should read this quote just because it's so critical. It is simply no longer possible to believe much of the clinical research that is published, or to rely on the judgment of trusted physicians or authoritative medical guidelines. I take no pleasure in this conclusion, which I reached slowly and reluctantly over my 2 decades as an editor of the New England Journal of Medicine. And that's a pretty wild statement when you think about it. But particularly over the last couple of years, I've really come to the conclusion that it's true. Now, institutional medicine, oh, there we go, yeah, Rose, has a very different culture, structure, and training from science and engineering and so on. And one of the critical pieces of that is there isn't an effective mechanism to make a kind of a high status MD reconcile their positions with the evidence. And that's was really kind of surprising to me. If you look at engineering, for instance, if you have the most senior engineer in the province and a new junior EIT engineer in training finds an error in their math, they don't agree to disagree, right? Yet the senior person doesn't get to say, well, I'm going to build the bridge my way, and you're just going to have to keep working at it to convince me, right? There are mechanisms in place that force a reconciliation of that position with the evidence. And the mechanisms are different, but they exist across, science, engineering, law, like a whole bunch of different fields. But after some conversations, even with some very senior people within medicine, those mechanisms don't really exist within, again, institutional medical hierarchies. I'm not talking about, your family doc here, right? But the people that get to positions of power and the constraints on how they can use that power. And there really aren't a lot, which again was just sort of stunning to me from a scientific perspective. And this carries over into publishing. So you'll find stuff in the medical journals that just would not fly in serious scientific journals. Like, yeah, okay, you can find everything in the fringe journals, but the kind of stuff you'd only find in the fringe in science winds up in fairly major medical journals. And I want to emphasize, I'm not saying like everything in the medical journals is junk, right? There's a lot of really good work in there as well. But the problem is there's not a lot of quality control. So you can get stuff published because it's great, but you can also get stuff published because you know the right people. And again, there's, I'm not saying that's not a problem in science, but as you'll see from some of the examples I'll show you in a moment, it's a really serious issue in medicine. So here's one representative example. So you've probably heard a lot of talk over the last few years about harms of respirators and masks and so on. And this is one paper that is pretty widely cited on that. So the title here, Respiratory Consequences of N95s in Pregnant Healthcare Workers, and it's a clinical trial, right? And with all the paperwork and expenses and all this stuff, that really kind of comes with running a clinical study. And they reported, interestingly, harm was not demonstrated, although that part often gets left out from where it's cited. But talking about significant changes to respiratory physiology caused by breathing through an N95 mask materials, right? And the materials part is important, you'll see in a moment, but also lost in translation. When it's cited, nobody talks about mask materials. They're saying N95s are harmful to pregnant healthcare workers. Widely cited, including in this key publication back in 2020 by the group that WHO policy was really relying on the advice from, arguing against the precautionary principle and use of respirators. And citations are all down the bottom if someone wants to follow up later. So, okay, interfering with respiratory function, that seems pretty serious, right? Well, how did they do that? Well, that's their experimental setup, right? So even without everyone's microphones turned on, I can almost feel like the cringe coming in through the windows. So this is what they did is they took this tight-fitting mask with a spirometer on the end. So all the air is flowing through this black thing on the end here with a little turbine inside. They cut a little piece out of a mask. Or an N95 respirator, looks from the label up here, or from the piece of the label, you can see it's a 3M 1860 or 1860S. And you can see I've highlighted in the text here, this is taken from their paper, simulating the actual wearing of an N95 respirator. Now, I got in touch with the manufacturer for the dimensions of that spirometer. I did a little bit of image analysis with ImageJ to figure out how much of it's covered in tape. And obviously, we only have the one picture, so it's not like a high-end value experimental system or anything. But there's about 12.5 square centimeters there. And the original mask, it'll vary a little bit depending on where the contact points on the face are of the wearer, but you're looking at about 150 square centimeters for the full 1860 on someone's face. So this experimental setup is a 10-fold reduction in available surface area, and I should thank, by the way, Connor Richicki for kind of finding this originally. He's the one that initially kind of pointed this out and wound up bringing it to my attention. But the net result of this is, because you're forcing all the air through this very small piece of surface area, in terms of resistance, it's like wearing 10 N95s, one on top of one another, and all of them well sealed, right? We've got tape around the edges of the piece of material, and then where the actual mask fits on the wearer's face, it's a elastomeric. So it's a 2015 paper, cited 79 times as of this morning, I just checked, and 73 of those include the term COVID. So essentially it's a paper that was produced, it kind of sat there in the literature and nobody did much with it. And then it's just taken off in terms of citations in terms of COVID. And it's cited as evidence that the breathing resistance of N95s causes physiological harm, or at least changes in physiological parameters, to pregnant women. And you can see, like, it just doesn't make any sense at all. There's a link to the Google Scholar if anybody wants to kind of dig into those citations of it. There's a lot more examples like this. So, I mean, Kevin kind of mentioned already the big three, like the LOA 2022 study on N95s versus medical masks, but there are a couple of previous studies as well, and the three of those together are often used to argue that respirators aren't better than medical masks in quote unquote real world situations. All three of those had protocols designed as intermittent use, right? So you walk into the room, you get within 3 feet of the aerosol source, and then you switch from a medical mask to an N95 respirator. And, right off the bat, that just tells you that there wasn't a lot of expertise in, respiratory protection involved in the design of these studies, right? You can't imagine, somebody in some kind of industrial process where they walk into the room 3 feet away from the source and then put on their PPE, right? It just doesn't work that way. But nevertheless, this is viewed as authoritative. One paper we've been dealing with recently, not directly related to PPE, but they claimed that PCC, so post-COVID condition or long COVID, is extremely rare in children. And you can see from the quote here, it says, met the WHO PCC definition. And then we've sent in a letter and they replied. And in their reply, they admitted, we would have asked about the 24 symptoms listed in this long COVID definition, but they didn't come out until after our study was finished. So there's a direct statement that they made claims in the paper and they never even collected the data necessary to assess whether those claims are true or false. And in any kind of field that I've been involved in, that would be a slam dunk retraction, right? Just over and done with. It's demonstrably false. That's the end. We're done. And not only was there no retraction, the journal actually played all kinds of games. Like if you go and have a look at it, their paper, which was widely covered in the media, is open access. Our letter and their response are hidden behind the paywall. They screwed around with our title after we had approved final page proofs. And just an unbelievable experience that, for me would be, I might expect something like that from a really fringe scientific journal, but none of the mainstream journals would behave like that. But this is JAMA Pediatrics and the JAMA Network, which really is, pretty well recognized name in the field. And it just goes on, right? Like I could spend hours on this. So again, I've got the citations at the bottom if people want to dig into that further. But it raises the question of how this happens, right? Like, how do we get to this place where, again, and I really want to make the point that I'm not saying that everything in the medical journals is bad, right? There's some really good work in there. The problem is that the system lacks these quality control methods, particularly for influential submitters. And so you can get really good things in the medical literature, but you can also get, like I said, stuff that you wouldn't see in the scientific literature outside the fringe literature. And a big part of the problem is this idea of a hierarchy of evidence, right? So this is actually taken from a World Health Organization, guideline development document. And a lot of you probably kind of run into this before. And we can go, like, again, we could kind of talk for hours about what does and does not work within the evidence-based medicine hierarchy. But part of the problem is that evidence-based medicine, it's a subjective policy on how to take shortcuts in interpreting science. So it's useful under the right circumstances, but the idea is that you've got a clinician, the time is limited, the resources are limited, they need to make some decisions, and so it's sort of a guideline to say, well, yeah, you don't have to learn the entire literature on everything, just sort of follow these guidelines and you'll get a kind of quick and dirty answer. And there's still debate about, so Dr. Greenhall and others have put some really great work out on, EBM plus, right? The idea that maybe it needs a little bit of tweaking even within that kind of intended application. But where we've hit a real problem is that it's been emphasized so much that this pyramid is critical, this is the way you have to decide, that people are graduating from these programs with believing that this is actually how science works, right? So not understanding that it's a heuristic, it's a shortcut, but actually thinking this defines the relative value of evidence from different sources. And it's just, there's no scientific basis for that, right? It's a policy that was adopted, and again, people even disagree internally about policy, but it's just a policy. And focusing in specifically, so up at the top here, we've got this kind of filtered evidence. From a scientific perspective, that's not evidence, right? Like when we run a PhD examination, the student kind of comes in and has to answer all the questions and everything. And what we tell them is the general stuff, know the textbook. Things that are getting, around your area of expertise, yeah, okay, reviews are useful there. But once we get to the hardcore of what you're supposed to know for your PhD, primary literature, there's no substitute. The reviews and that sort of thing are useful in the sense that it helps you find things in the primary literature and put it in context a bit. But primary literature is evidence, secondary, no. I put meta, maybe, like meta-analyses can arguably be considered primary literature because they do combine data from multiple papers and things, but you have to be really careful because there is a lot of opportunity for someone to put their thumb on the scales. And so, yeah, there's conceivably true, but in practice, a lot of them I don't see as super rigorous. Down at the bottom, this idea of putting animal and laboratory studies, there's no scientific basis for placing that there in the discussion of broader science. Debatably, it is useful as a shortcut, right? Like you don't want a frontline clinician going out reading a paper about mice and then inventing their own antibiotic dosing schedule or something. But nevertheless, yeah, the idea that somehow there's this ranking that's objectively true for science as a whole is just, there's no basis in reality for that. And then even within the ranking, methods do not override research quality. So randomized controlled trials are, people say gold standard, and tend to kind of argue that means if you have a randomized controlled trial, you can ignore everything below that. And again, that's, again, potentially useful as a heuristic, as a shortcut, but from a scientific perspective, no. You take all the evidence into account, and you may have done a randomized controlled trial, but if it's a terrible trial, then it has less evidentiary value than other aspects of this. And I'll just point out, like if you go down the bottom of the pyramid, in the second from the bottom, we've got narrative reviews, expert opinions, editorials, right? And you see that above animal and laboratory studies. And that is almost the original sin of the pandemic, from my perspective, is that there are significant numbers of people out there who legitimately believe, based on the training that they have received, that an expert opinion or an editorial from someone, inside the EBM bubble is actually of greater value than the entirety of animal and laboratory studies that have ever been completed. And so if you look back to the original rejection of the evidence on aerosol transmission at the World Health Organization, that I think is really what happened there, is that the people, receiving the evidence really felt like they were experts in their own minds. That meant that their opinions outweighed the entirety of the work done by these expert researchers in the bioaerosol space. So the last slide then, what can we do about this, right? And I would encourage people to get involved. So an MD is not the same thing as a PhD. It's not better, it's not worse, but the training is very different. And it's often kind of, I guess, sold to the public that and people outside academia in particular, that it's too complicated for you to understand. Just do what you're told, right? And I would say, don't go there, right? Like, if you see that those images I showed from the clinical trial on the N95 mask material with a tiny little circle cut out of it, right? There's nothing complicated about what was wrong with that paper, right? If you have a fairly basic background in this, you can really go through and you can often find some significant failings in some of this work that's been used as a foundation for policy. So the idea that it's too complicated for you is really like, people try and claim ownership about this. Don't think about this. Don't criticize my choices, my decision. But yeah, there's no basis for that. You'll often hear the term epistemic trespass, right? The idea of stepping into someone else's area of expertise and telling them how it works. And that's used again to kind of shut down debate. But I think it's really useful to make a distinction between what I call authoritarian epistemic trespass. So that's if I step into your space and I tell you, I know how this works. I'm right, you're wrong, stay out of my way. The other option is inquisitive epistemic trespass, right? So where you kind of step into the space respectfully, but ask questions and try and understand what's going on. And that's where, it's not for me to step into the cockpit of an airplane and suddenly tell the pilot, you should be doing it this way. But it's okay for me to look out the window and say, hey, are we really supposed to be flying straight at this mountain, right? So if you see suspicious research, right, if you see something cited that says, talking about these ridiculous harms from N95s that everyone's going to, drop dead in 10 minutes after putting one on, and or toxic levels of CO2 and all kinds of things, look into it yourself and speak up about it. Don't be intimidated. Don't feel like the people doing these studies must know much more than you do about this. Again, especially in the medical literature, the people doing the study may not have any more advanced science training than you do, right? So really, feel confident. Make sure, know yourself, right? Know your own limitations. Don't repeat the errors we've seen in the pandemic where people just kind of overconfidently start stomping all over things. But yeah, regardless of your background, like I said, so these failures that we're seeing are not, some of them are quite technical and complex, but many of them are quite straightforward. And the other piece of that is there's just so much junk out there that we really need your help. There's a bandwidth limitation. Individuals like myself who are kind of faculty and trained in this area, there's a certain amount we can do, but there's only so many hours in the day. So it's really valuable to have community involvement in this, kind of digging into the questionable claims and highlighting areas where there's real problems. So I will end there and stop sharing. Oh, and I saw Dorothy has posted a link to a paper. Yeah, thank you. That's a really great paper.
Thanks, Dr. Mark Engren. What we might do is